Now we are moving to the conversion of octal to decimal. Our first question is to convert 601 in the octal system to the decimal number system. So what we have to do is to represent the decimal equivalent will be represented by y, and to represent that digit with the power of the base. The position will be 0, 1 and 2. So 6 multiplied by 8 to the power of 2 plus 0 multiplied by 8 to the power 1 plus 1 multiplied by 8 to the power 0. So it becomes 6 into 64 plus 1, that's equal to 385. So this will be the decimal equivalent of the 601 in the octal number system. So this is how to convert this. Now moving to the next problem consisting a both integer part as well as a fractional part. So here I have to mark the position 0, 1 and it will be minus 1. Okay, so the decimal equivalent of this number will be 5 multiplied by 8 to the power 1 plus 7 multiplied by 8 to the power 0 plus 4 multiplied by 8 to the power minus 1. So it becomes 40 plus 7 plus 4 by 8. That means 47.5. Okay. So this is the decimal equivalent to this 57.5 in the octal number system. Now moving to the next conversion is the hexadecimal to decimal. Okay, so here what we have to do is decimal equivalent of this number will be 0, 1 and minus 1. So 5 multiplied by 16 to the power of 1. Here it is an hexadecimal number system, so the base will be 16 plus 7 multiplied by 16 to the power of 0 plus 4 multiplied by 16 to the power negative 1. So it becomes 87.25. Okay, now moving to the next question, that is BAD in hexadecimal to decimal. So here B corresponds to, here the position is 0, 1 and 2. In hexadecimal system the value of B equal to 11, A is 10 and D will be 13. So we have to replace these alphabets with the numeric values. Therefore the hexadecimal equivalent will be B into, what is B? 11. 11 into 16 to the power of 2 plus 10 into 16 to the power of 1 plus D is 13. 13 into 16 to the power of 0. So it will becomes 2989. So this is the equivalent decimal value for this hexadecimal number. Okay, so we have finished how to convert different numbers to the decimal number system. Now we are moving to MSB and LSB. MSB is the most significant bit and the least significant bit. Consider here a binary number. Here I have considered 10111. Okay, I have represented its position with B0, B1, B2, B3 and B4. The two extreme end bits will be the significant ones. Among these, which is the most significant and the least significant? To identify that, I have converted this binary number to its equivalent decimal. Okay, you know how to convert that. Its decimal value will be 23. Now, I have replaced this B0. It was already 1 and I have replaced it with 0. Now, the binary number will become 10110. The decimal equivalent of that number will be 22. Okay, when I change the bit B0 to 0, the decimal value will become 22. Now, I have replaced B4. It was already 1 and I have changed it to 0. Now the decimal equivalent of this number, that is 00111, becomes 7. Okay, which means a huge difference is obtained when I change this bit, that is the B0. Okay, that means among these bits, the most significant bit will be this one. That this is our MSB, and the least significant bit will be this one. So this is our MSB and this is our LSB. That is for a binary number. This extreme will contains the MSB and this extreme will contains the LSB. Okay. Now we are moving to the next conversion, that is from decimal number system to binary. Okay. So to do this, here the question is 13 in decimal to binary number system. So here we have to divide the number to be converted with the base. The base value of binary is 2. Okay. So I am going to divide it with its base value, and we have to note down the quotient as well as the remainder. So it becomes 6. Here 6 is the quotient and the remainder will be 1. Okay. Again divide the quotient with the same base. 2. Here and note down the quotient and the remainder. It becomes 0. Okay. Again divide it with 2. 1. 1. Repeat the procedure. 1. And stop until we met with a 0 at the quotient. Now this is our equivalent binary, that is the 1011. But how to write it? Which one is the LSB and which is the MSB? If we are doing like this, then this bit will be our MSB and this will be our LSB. Okay, so the binary equivalent of 13 in decimal will becomes 1101. Okay, this is the equivalent binary number.